Sample question 2. Transformation of graphs. The diagram shows the graph of the quadratic function f. The graph meets the x-axis at 1, 0 and 3, 0, and the minimum point is 2, minus 1. Part A. Find the equation of the graph in the form y equals f of x. We're told that the graph is of a quadratic equation, so there will be a maximum of two roots to the equation f of x equals 0. Since the graph crosses the x-axis at 1 and 3, we can deduce that the factors x minus 1 and x minus 3 will be involved in creating our quadratic equation. We can therefore write the equation in the form y equals a times x minus 1 times x minus 3. Substituting the minimum point coordinates of 2 and minus 1 into the equation for x and y, we end up with a equals 1. So our factorized equation is y equals x minus 1, x minus 3. Multiplying out the brackets, we end up with our quadratic y equals x squared minus 4x plus 3. If you want to find where the graph crosses the y-axis, you plug in 0 for x in our equation and we find y equals 3. So the graph crosses the y-axis at plus 3. Part B. On separate axes, sketch the graphs of y equals f of x plus 2 and y equals f of 2x. For part C, we have to write the coordinates of the minimum point, so I'll answer B and C together for each graph. For the y equals f of x plus 2 graph, as we have to add 2 to x before performing the function, it means a translation in the x-axis of minus 2 units, i.e. the graph is shifted left by 2. The coordinates 3, 0 move to 1, 0, the old coordinates of 1, 0 move to minus 1, 0, and the minimum point moves from 2, minus 1 to 0, minus 1. Alternatively, we can find the new axis crossing points by substituting x plus 2 for x in our equation. Multiplying out the brackets and simplifying, we end up with x squared minus 1. This is a difference of two squares and can be factorized into x plus 1, x minus 1, which gives our new x-axis cross at minus 1 and 1. To find our new y-axis cross, we plug in 0 for x and get y equals minus 1. For the y equals f of 2x graph, as we have to multiply x by 2 before performing the function, it means we stretch the graph along the x-axis by scale factor a half. So every x coordinate is a halved, and the graph is therefore actually squashed horizontally. The coordinate 3, 0 moves to 1.5, 0, 1, 0 moves to half 0, and the minimum point 2 minus 1 moves to 1 minus 1. If the coefficient of x was a fraction less than 1, then the scale factor would be greater than 1, as it is the reciprocal, and the graph would stretch outwards horizontally. An alternative way to find the new crossing points is to substitute 2x for x in the equation. In this case, I will substitute into the factorized form. Setting the equation equal to 0, I find that the roots are a half and 1.5. To find the y-axis cross, I substitute 0 for x in my new factorized equation and end up with y equals 3.